All right, let's talk about this little thing. We've all seen it, right? The Rubik's Cube. It's colorful, iconic, and yeah, it's sometimes a little frustrating. But for just a few minutes, let's forget everything we think we know about solving it. We're going to look at how this puzzle is actually one of the very best first math toys a kid could ever have.
So right off the bat, we're changing the question. The real magic of the cube for a young mind isn't in finding the solution. It's in the simple act of looking. When we shift from "can you solve it" to "hey, what do you notice?" well, you transform a test into an invitation. It becomes all about wondering, not winning. And that leads us right into our first big idea. We have to reframe what this cube even is. So let's stop seeing it as some kind of pass-fail exam or a speed competition. Instead, let's treat it like a tool, a fantastic conversation starter for exploring colors, patterns, and how things move and change.
I mean, think about it. This little object in a child's hands can be the beginning of a story they make up about what they see. It can be a little canvas for making cool patterns. It's a real, physical thing that gets them thinking mathematically, but with absolutely zero pressure.
Okay, so once you've sparked that curiosity, the cube becomes something else, something really powerful. It turns into a tool for building language. We can actually use it to learn how to talk like a mathematician, just by looking and describing what we see.
You know, this is where math really begins. It's not with numbers on a page. It's with noticing. We just observe and we count. How many sides or faces does it have? 6. How many little squares on each face? 9. A child can literally point and count and compare. It's this tiny little world they can hold in their hands.
And this totally redefines what we think of as math words. For a little kid, just naming the colors is an act of sorting and classifying. And using words like top, middle, or center, that's their very first lesson in spatial reasoning. That's geometry.
Now, with just one single twist of the cube, a child can discover one of the most basic ideas in all of science and math. You make one little move and poof, some things are in a totally new spot, but other things haven't moved at all. This idea of things that change and things that stay the same, that is a huge concept.
And here's the perfect illustration of that. The centerpiece on every face. That's the anchor. It doesn't matter how many times you spin that side. The orange center is always the orange center. It becomes a landmark, a reference point, teaching kids that even when things are changing, there are some things you can count on.
Okay, so let's zoom in even closer. If we really look, we start to see that not all these little pieces are created equal. They each have their own identity, their own little story to tell. See, this is the hidden rulebook of the cube. A centerpiece, it only ever shows one color. That's its job. An edge piece, the ones that sit between two centers, will always show two colors. And a corner piece will always show 3. It's not random at all. It's a fixed, predictable system. That's what we call structure.
So we've looked at the pieces. Now, what about the actions? A turn isn't just scrambling things up randomly. No, it's a very precise, repeatable move. You can almost think of it like a little dance with very predictable steps.
Just watch this. If you turn the right side once, then twice, then 3 times, and then a 4th time, look at that. You're right back where you started. This shows kids that a series of actions can create a cycle that you can predict, and that is the very beginning of understanding what an algorithm is.
And this leads to another just incredibly cool mathematical idea, the inverse. For every single action, there's an opposite action that can undo it. The cube takes this really abstract idea and makes it something a child can actually hold and feel.
And this shows it perfectly. You make one turn clockwise, we'll call it R for the right side, the cube changes. Then you make one turn counterclockwise, we'll call that R prime, and boom, you're back to the start. You did something, and then you undid it. That's thinking backwards, and that is such a critical skill.
So if these moves are so specific, does that mean we can write them down? You bet we can. And when we do that, the movements of the cube suddenly become a language, almost like a secret code.
Now, I know this might look a little intimidating at first glance, but it's really as simple as learning your ABCs. Each letter is just a shorthand for one face. R for right, L for left, U for up, you get the idea. This is how we turn a physical action into a written instruction. That's the heart of computational thinking, right there.
Okay, so we've talked about all these amazing ideas hiding in the cube. Now for the really fun part. How can you actually do this with a kid?
This last section is all about playful, simple activities that invite them to think like a mathematician. Here's your starter kit, and notice, none of these are about solving anything. Color Hunt is just about searching and grouping. Same and Different is all about noticing that structure we just talked about. Turn and Tell is simply about describing change. These are easy games, but they have some really big math ideas baked right inside.
But in the end, it all comes down to the kinds of questions we ask. Look at these. None of them have a single right answer. They're open invitations to just think. What changed? What stayed? Prompts that amazing observation about constants. And my favorite, how do you know? That asks a child to explain their thinking. This is how you build a mathematician.
And that really gets to the heart of this whole thing, doesn't it? The object itself is small enough to fit in the palm of your hand, but the thinking it inspires, thinking about patterns and structure and change and logic, that is absolutely enormous.
So I'll just leave you with this final thought to chew on. What if we all kept a cube lying around, not as some challenge to be conquered, but as an open-ended playground for the mind, as a tool for curiosity and conversation, and just joyful thinking? It's serious math, just in a playful disguise.